America's wars have always demanded more than just firepower. Sometimes victory comes down to the muscle of a machine. Hidden in plain sight, a handful of U.S. Army trucks have hauled 70-ton tanks, thundered through live fire, and survived blasts meant to shatter steel. But only a select few made the cut as the strongest ever built. Just how did these massive machines push engineering and soldiers to their absolute limits? The true answer begins at the edge of battlefield weight class. The late 1970s brought a new kind of heavy hauler to the U.S. Army's arsenal. The M911, built by Oshkosh, stood out with its 8x6 drive layout and a Detroit diesel 8V92 V8 engine delivering 450 horsepower of raw power. At nearly 40,000 pounds curb weight, this tractor was engineered to pull a combined load of up to 190,000 pounds when paired with the M747 low-bed trailer. That meant moving 60-ton tanks and heavy engineering equipment over long distances, a task that demanded both muscle and precision. What set the M911 apart wasn't just raw power. Behind the cab, 2 hydraulic winches, each rated for 45,000 pounds, gave crews the ability to haul disabled tanks or armored vehicles directly up the trailer ramps. The system was designed so that, instead of relying on external cranes or cumbersome rigging, the truck's own winches reinforced oscillating fifth wheel, and the low-slung trailer worked in concert. A tank could be winched up from the ground and secured for transport in forward areas, all with the tools built into the truck itself. This self-loading approach meant faster recoveries and fewer support vehicles needed on the battlefield. The M911's air-suspended pusher axle, heavy-duty rear bogie, and adjustable fifth wheel allowed it to manage the shifting loads and steep approach angles required when loading tracked vehicles. On level roads, the M911 could maintain 43 miles per hour fully loaded and still keep moving up a 3% grade at 14 miles per hour. Operating in temperatures from -25 to 125 degrees Fahrenheit, the M911 proved its worth during the Cold War, bridging the gap between Vietnam-era transporters and the demands of modern armored warfare. Its strength was structural engineering and haulage, not battlefield protection. The cab and chassis remained unarmored, focusing all resources on moving the Army's heaviest machines. The innovations tested here would push designers to develop even more capable transporters in the decades that followed. When the U.S. Army needed to move a new generation of main battle tanks, a new breed of heavy equipment transporter was born. The Oshkosh M1070 heavy equipment transporter, paired with the M1000 trailer, set an entirely new standard for military haulage. Under the hood, a Caterpillar C18 diesel engine delivers a staggering 700 horsepower, pushing 8 driven wheels through an Allison automatic transmission. The M1070's gross combination weight rating, when loaded, tops 115 tons, more than enough to carry a fully loaded M1 Abrams plus support gear across highways, dirt tracks, or desert sand. What distinguishes the M1070 is not just its raw numbers. The truck's central tire inflation system lets crews adjust tire pressure on the fly, switching from hard pavement to deep mud or soft sand with the push of a button. This simple control makes the difference between a column bogged down in hostile terrain and a convoy pushing forward at full speed. Heavy-duty suspension and a reinforced fifth wheel absorb the punishment of uneven ground, while dual hydraulic winches give recovery crews the power to load even battle-damaged armor without outside help. On the proving grounds, the M1070's strength is not just theoretical. In a NATO road march exercise across Eastern Europe, convoys of these trucks hauled tanks and engineering vehicles over hundreds of miles of rough roads and steep grades without a single breakdown. The 700 horsepower powertrain shrugged off hills and heat, keeping pace with the demands of rapid deployment. With the M1070, Oshkosh delivered more than a truck. it delivered the backbone of modern armored mobility, capable of towing the Army's heaviest assets wherever the mission demands. This is the benchmark every other heavy hauler is measured against, and nothing else on wheels comes close. 10 tons of fuel or ammunition, loaded and rolling over open desert, is the difference between a stalled offensive and a breakthrough. The Oshkosh HEMTT, Heavy Expanded Mobility Tactical Truck, was built for this moment. With an 8x8 drivetrain and a Detroit diesel 8V92 turbocharged engine pushing out 450 horsepower, the HEMTT does not just haul cargo. It brings the lifeblood of an armored force all the way to the front. Its off-road payload rating, 10 tons even in mud or sand, puts it in a league of its own among military logistics trucks. During the April 2003 Thunder runs into Baghdad, HEMTT fuelers and ammunition carriers became as critical as the tanks they supported. Convoys raced through hostile territory, refueling M1 Abrams and Bradleys under fire. Soldiers from the 3rd Infantry Division described how HEMTT trucks took small arms and RPG fire while topping off tanks just yards from the front line. Without these trucks, the armored spearheads would have run dry, losing their momentum at the gates of Baghdad. HEMTT trucks kept the advance moving, proving that logistics under fire demands as much muscle and nerve as any combat maneuver. Desert mobility is more than a spec sheet. The HEMTT has independent suspension and massive tires that absorb shell-pocked ground, berms, and sudden detours. Its 300-mile range means fewer stops, more reach. Every variant, fueler, cargo, wrecker, shares the same backbone, a chassis engineered for relentless punishment and a drivetrain built to keep moving when everything else bogs down. In modern warfare, the ability to deliver 10 tons of fuel or ammunition through chaos and over any terrain turns a logistics truck into a combat enabler. The record of the HEMTT on the battlefield proves it. When the mission is on the line, 10 tons at a time, this is the truck that answers the call. A new era in Army logistics arrived with the Oshkosh Palletized Load System, called PLS. Unlike any truck before it, the PLS delivered a breakthrough in how supplies move from rear depots to the front lines. At its core is a heavy-duty hook lift system that redefines battlefield throughput. Where earlier trucks relied on forklifts, cranes, or teams of soldiers to load and unload, the PLS can pick up or drop off a 16.5-ton flat rack or ISO container in under 60 seconds, all without leaving the cab. The system's 8x8 chassis, paired with a robust diesel engine in the 400 to 500 horsepower range, means it can handle the same punishing terrain as the HEMTT, but with a new level of efficiency. The real advantage comes from the self-loading flat rack. The operator backs up, engages the hook, and the hydraulic system lifts the entire load smoothly onto the truck bed. The process reverses just as quickly, allowing the PLS to deliver ammunition, fuel, or even bridge sections, and then move on to the next assignment without delay. This single innovation slashed the time and manpower needed for resupply missions. On a modern battlefield, where every minute counts, the PLS's ability to cycle loads faster than any previous truck transforms logistics from a bottleneck into a force multiplier. Crews are less exposed, convoys are leaner, and supply points can shift forward with unprecedented speed. The Army's adoption of the PLS after the Gulf War marked a decisive move toward containerized, rapid-handling logistics, setting a new benchmark for what a tactical truck could achieve in both power and operational tempo. The family of medium tactical vehicles, known as FMTV, redefined what it meant to be strong through engineering commonality. Each truck in the lineup, from 2.5-ton 4x4 trucks to 5-ton 6x6 trucks, shares a core chassis and driveline. This approach streamlines maintenance and parts supply across the entire fleet, but the real test of strength comes in the field. At the Nevada Automotive Test Center, FMTV trucks faced relentless high dust, high-temperature runs loaded to capacity. Independent suspension systems, a major upgrade in the A2 generation, absorbed punishing impacts and kept wheels planted through deep ruts and washboard terrain. Test logs from the Nevada Automotive Test Center document repeated full-speed passes where the trucks maintained control and ride stability, even as dust choked the course and temperatures soared above 100 degrees Fahrenheit. With a 330 horsepower diesel engine under the hood, the FMTV family delivered both the power and the reliability needed for modern missions. The result is a fleet that proves its worth not just by hauling cargo, but by surviving the Army's harshest trials day after day across every variant. In the early 1990s, the Army's M939 series 5-ton trucks faced a crisis that had nothing to do with enemy fire. Accident reports showed a sharp rise in fatal crashes, at least 65 deadly incidents, and 83 lives lost between 1985 and 1998. Investigations revealed a troubling pattern: loss of control during hard braking, especially on wet or icy roads, often led to rollovers or jackknifed trailers. The M939's full air brakes, designed without anti-lock systems, proved unforgiving in emergencies. When drivers slammed the pedal on slick surfaces, the wheels locked and sent the 10-ton truck skidding, turning a workhorse into a runaway threat. Army engineers and safety officials pored over the data. The numbers were clear. The M939 was more than twice as likely to be involved in a fatal crash compared to other tactical trucks. The solution was both technical and urgent. In the late 1990s, the Army launched a fleet-wide retrofit, installing modern anti-lock braking systems on thousands of M939s. Anti-lock braking system kits, wiring harnesses, and new hardware flowed to depots and National Guard shops across the country. Over the next decade, most active M939s received the upgrade. The result was a dramatic drop in loss of control crashes, restoring trust in a truck that had carried the Army for years. Safety, once an afterthought, became a core part of what made these trucks strong. Across the Army's sprawling supply routes, the M915 series line haul tractor became a workhorse for moving containers, fuel, and ammunition between depots and forward bases. Designed as a 6x4 commercial-style road tractor, the M915 was prized for its efficiency on highways, but its limitations off-road were well known. By the 2000s, heavier loads and new armor kits pushed the platform to its limits. Army planners studied a midlife modernization, eyeing a 420 horsepower diesel upgrade for more pulling power and better gradability. The idea was straightforward: repower the existing fleet to keep pace with modern demands, using off-the-shelf commercial engines and drivetrains. But the debate quickly turned to cost versus capability. Critics questioned whether more horsepower alone could solve the M915's fundamental weakness, its dependence on paved roads. As roadside threats escalated and convoy routes grew less predictable, the Army weighed whether to keep investing in a specialized road tractor or move toward a common tactical truck, an 8x8 design promising both line haul power and tactical mobility. Common tactical truck studies highlighted the advantages of a unified, modular fleet, able to handle both highways and rough terrain without compromise. The M915's future hung in the balance, caught between incremental upgrades and a push for a new generation of all-purpose military trucks. Roadside bombs and buried mines changed the battlefield almost overnight. In Iraq and Afghanistan, improvised explosive devices tore through soft-skinned vehicles, turning routine supply runs into deadly gambles. The Army's answer was the MRAP, Mine-Resistant Ambush Protected Truck, designed and fielded at a pace rarely seen in military procurement. At the center of this response, the MRAP Program Office coordinated a surge that delivered thousands of armored trucks within just a few years. Survivability became the new measure of strength. The Oshkosh M ATV, one of the most advanced MRAP designs, was built for the mountain roads and rugged trails of Afghanistan. Its V-shaped hull deflects the force of underbody blasts, channeling deadly energy away from the crew. With a 370 horsepower diesel engine and high clearance suspension, the MATV can climb steep, broken terrain that would stop heavier armored vehicles cold. Pentagon reviews credit these trucks with sharply reducing fatalities from roadside bombs. The MATV's protection, speed, and off-road agility set a new standard, proving that the strongest trucks are built not just to haul or tow, but to bring soldiers home alive when the threat is everywhere and the road itself is the enemy. The HEMTT A4, the Humvee, rolled out in the early 1980s as a leap ahead in mobility and versatility, but its first real test came in Operation Just Cause in Panama in 1989. With a 6.2-liter V8 diesel producing around 150 horsepower, later boosted to 190 in upgraded models, the Humvee was built to tackle mud, jungle, and broken roads. Early versions were unarmored, relying on speed and maneuverability to keep crews safe. But as missions shifted from open terrain to city streets and ambush-prone convoys, the Army began fitting Humvees with armor kits, steel doors, ballistic glass, and underbody plates piled on thousands of pounds, straining the original chassis and suspension. The 190 horsepower engine now had to move a truck that weighed nearly twice its original specification, and the added armor pushed brakes, axles, and the driveline to the edge. Reports from Iraq and Afghanistan described up-armored Humvees struggling through soft sand and steep grades, sometimes overheating or breaking down under the load. The more protection crews bolted on, the less mobile the truck became. This vulnerability, caught between the need for armor and the limits of a light utility platform, drove the Army to seek a new answer, setting the stage for the next generation of tactical vehicles. The Joint Light Tactical Vehicle, JLTV, stands as the Army's answer to a new era of threats, where speed and protection cannot be separated. Under the hood, a 340 horsepower diesel engine drives all four wheels through an advanced independent suspension, delivering a power-to-weight ratio that leaves the up-armored Humvee in the dust. The JLTV's real edge comes from its modular armor system. Crews can add or remove ballistic panels in the field, scaling protection to match the mission and the terrain. This approach keeps weight down when speed matters and lets the truck absorb small arms fire, shrapnel, and even blasts from roadside bombs when conditions demand it. Compared to the Humvee, the JLT5 offers twice the mobility in rough terrain, with ground clearance and suspension travel that let it charge across rocks, ditches, and broken ground at speeds that would snap older trucks in half. The digital dash and integrated communications turn the cab into a rolling command post, ready for networked operations. Every detail, from the armored floor to the quick change armor kits, reflects lessons learned in Iraq and Afghanistan, where every pound of protection had to be balanced against the need to move fast and stay agile. The JLTV is not just a replacement, it is a future-ready platform designed to keep pace with changing battlefields and threats. Steel and horsepower still decide what gets through the world's most dangerous terrain and what does not. As new threats emerge, the Army's demand for stronger, smarter trucks only grows. Every upgrade is measured in lives saved on the front lines. In the end, the true strength of these machines is the difference between coming home and becoming history. For more stories of military innovation, subscribe and join the conversation below.